So today we are talking about 8.5, solving equations. And we're going to handle this just like we did the previous notes, where we get a common denominator first, and then we'll have an equation to solve. So just basically algebra after that. Before we get into that, let's talk about finding the least common denominator or the lowest common denominator. That's what that LCD means. This is what we've already been doing. I just called it the common denominator, but when I was doing it, I was finding the LCD. If you don't find the lowest common denominator, your final answer will not be completely correct because it will not be fully reduced. And that's not something I really want to focus on necessarily to avoid confusion. So your goal is to find the lowest common denominator, not just any common denominator. Emphasis on the lowest. Now, a couple of you ran into this issue on the previous homework because there was a problem like that was there to kind of trip you up and make sure you're finding the lowest common denominator. Let's look at number 1. 4x and 6y, if those were the denominators, we need to find the LCD of the 3 of those. Let's start with the easy part. Reminder, if it's present in any of the denominators, it must be part of the LCD. Letters, numbers, all of it has to be part of it. So let's start with the letters. There's an x, so of course there will be an x in my LCD. Reminder, I can't take anything away, I can only add to it. Y, there's a y, so it will also be present. The big question here is, what is the number going to be? Because I've got 2, I have 4 and 6. And I can't turn the 4 into 6. There's 4 times something nice is going to give me 6. It's not going to happen. So we're going to have to find a different number. Now, a lot of you will look at that and go, oh, well, I could do 4 times 6, that's 24. That would be a common denominator, but not the lowest common denominator. There is a number smaller than 24 that will work. I know a few of you already know it. I'm going to have you hold off. So if you're not sure how to find that number, if it's just not coming to your head, I'm going to show you a couple ways to get there. This first way works all the time. It's just a little tedious, but it's not hard. We can write out the multiples of both of those numbers and see where you find the first matching number. So I'm going to start with the 4. And you don't have to write out like the first 10. Let's just go like the first 4. And this is just the multiples of 4. So if I were to multiply 4 by 1, then by 2, then by 3, this is the list. 4, 8, 12, 16. So the first 4 multiples of 4. And just keep adding 4. I'll do the same for 6. 6, 12, 18, and 24. Looking at both lists, you can already see that they have a number in common, and that number is 12. That is the LCD. That is what you want to find. So our LCD is 12xy. So that's a way to always find it. Again, it's a bit tedious, but it's not difficult. Just takes a moment to write everything out and then find the lowest number. Now there is a trick to getting there a little bit faster that I'll show you in the next problem. Number 2, 5x squared, 3x cubed, and 2x. New problem. The goal is the same, find the LCD. We'll come back to the numbers in a moment. Let's talk about the letters. They all have x's, so of course there will be x in the LCD. And remember, I can add to, but I can't take away. So you just need to grab the largest number of x's, which is 3. So x cubed, that's how many I need. I have some students that are going higher than that. They're adding how many x's they have total. You don't need to do that. That would not be the LCD. Just take the biggest one. All right, numbers. When you have 3 numbers to work with, that complicates the process a bit more. You'd have to write out 3 separate lists. So let me show you a little bit of a shortcut that'll save you some time. So I'll just call this a little trick. Write out the multiples of the largest number. My 3 numbers are 5, 3, and 2. 5 controls what the denominator can be because we can't get smaller than 5. It's not possible. So we're going to go with whatever 5 dictates. So let's start just by writing out the factor or the multiples of 5. So we'll go 5. I'm just going up from 5 from here. 5, 10, 15, 20. I'll stop there. We've gotten 4 out. Now let's go over strategy. You want to visit each number and ask, can I divide this number by 3? Can I divide this number by 2? When you answer yes to both of those questions, you have found the LCD of these 3 numbers. Obviously, I can't divide 5 by 2 or 3, or else I wouldn't have even made the list. 10, I can divide by 2. It's even. I cannot divide by 3. And reminder, if you ever have a question about whether you can divide 2 numbers, use the calculator. That can help with that. 15, I can divide 15 by 3. It's 5, but I can't divide by 2. It's not even. 20, I can divide by 2, but not by 3. So I'm not at the LCD yet. Let's keep going. 25 does not work for either of those numbers. 30. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 is going to be my number. And I'm going to write out that work just to show you what I'm looking for. 30 divided by 2 is 15. So we get a nice number, not a decimal. And 30 divided by 3 is 10. Also a nice number. So we're going to use 30. $30 is in the LCD. So when you get this kind of problem, if you are having trouble finding the right number for the LCD, you can either write out the lists for all the numbers, or you can write out the list for just the biggest number, and then use your calculator from there to figure out which LCD is going to work. And on number 2, I could have written out lists for 2 and 3 as well, but those would have gotten a bit long, would have taken me more time. So there you have it. All right, let's visit an actual problem, and we're going to use that trick in just a moment that I showed you. 1/4 plus x equals x over 10. Just immediately, I'm sure that is probably scaring a few of you just looking at this problem. It was like, oh, that's a lot. It's not, I promise. We already know how to start the problem because of the fractions, what we've been doing this whole week. First thing I want to do is I want to turn that x into a fraction. That'd be helpful. So we can just put it over 1. If you ever have something by itself, it's not a fraction, put it over 1. Now you have a fraction. All right. First thing we want to do is get the LCD, the common denominator, on all 3 fractions, just like what we've been doing since Monday. So I'm going to rewrite the problem. 1/4 plus x over 1. Leave a bit of space after that one before the equal sign because you're going to need space to write what you're multiplying by. Equals x over 10. And we need to find the LCD. Looking at our denominators, we have 4, 1, and 10. We could ignore the 1. So we're looking at the LCD of 4 and 10. Again, if you look at it and go, oh, 4 times 10, 40, I'm going to use that. That is not the LCD. It is a common denominator, but not the lowest one. So you can either write out the multiples for 4 and 10, or I'll just use the trick. I'm going to write out the multiples for just the larger number, 10. So I'm going to take 10 and I'm going to make its list. And I will not have to go far at all. First number is 10. Obviously, 4 does not go into 10, or I wouldn't have done this. Next number is 20. Can I divide 20 by 4? Yes. 20 divided by 4 is 5. It works, so I can use 20. My LCD is 20. And I have no letters in these denominators, so it's just a number on this problem. Now that I found my LCD, I'm going to transform all 3 of these fractions. I'll write out my goal fractions first. So we want all of these to be 20. And let's figure out what we need to do to change all 3 of these. First fraction, 1 over 4. We need to do 4 times 5 to get 20. So times 5 on the top. 1 times 5, this is now 5 over 20 for the first fraction. I'm going to fill in my plus and equals before I forget that. Next fraction, I just have a 1, so that completely needs to be changed to 20. Times 20, top and bottom. X times 20, you just put them together, 20x. Equals, last one. To get from 10 to 20, it's times 2. So times 2, top and bottom. X times 2, that's just 2x. So far, aside from showing you this trick to get the LCD, I've not shown you anything new that I've already shown you since Monday. This is step 1 of the problem, what we just did here. Get the LCD, lowest common denominator, on all fractions. So all 3 fractions have to match, same denominator before we do the next step. You guys are not ready for this next step. Obviously, this looks difficult. I promise it's not. This next step is going to feel illegal, but I promise you 100% you are allowed to do this. We're going to drop those denominators. 5 plus 20x equals 2x. Step 2. Drop the denominators. Since we are solving an equation, that's why I'm dropping the denominators. Once the bottoms are all the same, then it must also be true from the top. That equal still applies. So if you're solving an equation, that's when you're allowed to drop the denominators and then just focus on the equation that's left over. This is an algebra trick. It's one of my favorite ones. I used it all the time in college. So it is a wonderful thing to know about. Now, we have an equation. Let's solve it. To start the solving, I'm going to rewrite the problem. And step 3, solve the equation. I know it's been a minute, but we've got this. 5 plus 20x equals 2x. I want to take a moment. Whenever this scenario appears where I have an x on both sides of the equation, a lot of students freeze. They forget. What do I do? What do I do when I have an x on each side? What'd you say? Nope, no squaring. Jordan?
Move the 20.
Yes, you move one of them, and I agree, I'm going to move the 20. When you have them on opposite sides, we're not going to combine. That's why I draw the line there, so we don't combine across the equal sign. We're going to have to move one of them, and since the 2x is all by itself, I'm going to leave it there. We'll move the 20 instead. That's a positive 20. I will subtract 20 on both sides. Bring down the 5. And you can cancel out the 20s if you like. Bring down the 5. 2 minus 20, that's negative 18. Don't forget the x, negative 18x. One more step and that's it. What is my final step?
Divide by 18.
Yep. You divide whatever is attached to the x. So I'm going to divide by negative 18. Leave the x on the right side. It's doing all right over there. X equals, and you can keep the negative on the bottom, but I always like to put it on the top. That's just me. Negative 5 over 18. And I already see some of you doing it. You are more than welcome to check and make sure that doesn't reduce. I can tell you for certain it does not. So I'll save you that step. But do check that when you get a fraction. Make sure you can't reduce it. That's it. We're done. Questions on the process, the steps. Common denominator, drop the denominators, solve the equation. Give you guys about 30 seconds, those of you still writing, and then I'm going to move on. So, I've got one more thing to show you. And the reason we didn't talk about it yet is because it didn't apply to that first problem. I just wanted a nice, easy problem to show you how to do it. But there's one more thing you have to be aware of, and those are extraneous solutions. We've talked about extraneous solutions before. Those appeared last semester in a couple units, and then also we have talked about this during this semester as well. I distinctly remember 5-8, we talked about extraneous solutions. If any of the denominators have a variable, so for instance, that variable could be x, usually is x. Sometimes we'll put other letters in to mix it up. Then your problem may have extraneous solutions. Can someone explain or describe what an extraneous solution is, what it does? Anybody got a clue? As the word implies, these are extra solutions or extra answers. The problem with these answers is they don't actually work. Extra answers that don't actually work. Another easy way to remember this that I came up with last period, you could also refer to these as fake answers. So if your final answer is an extraneous solution, is a fake answer, the answer to the problem is actually what? No solution. If you get a fake answer, it doesn't work. Your actual answer is no solution. So I'm sure your next question is, well, Mrs. Johnson, how do I know if I got a fake answer? I will show you. We will, at the very beginning of the problem, identify what these fake answers are. We'll make a list of them. We'll keep an eye out. We'll solve, and then we'll make sure that the answer we got wasn't the fake one. It's that straightforward. Okay, let's start this problem per usual. Number 4, 5 over x minus 2 plus 2, let's make that over 1, equals 17 over 6. And I'll put that x minus 2 in parentheses just for good measure. Very first thing we need to do is find the LCD. Now, I don't know about you, but I feel like this LCD is pretty easy, pretty self-explanatory. What is the LCD? Yes, but what is it? Doesn't require any math, guys. Exactly. Our denominators are x minus 2, 1, which we can essentially ignore, and 6. So our only option here is to just put them together. 6, x minus 2. I can't turn x minus 2 into 6, and I can definitely not turn 6 into x minus 2, so we just use both. Put them together, there's your LCD. Now we're going to take a moment and switch gears here. This is how we're going to be able to figure out what extraneous solutions are. Reminder of the directions above. If any of the denominators have a variable, for instance an x, we do. This denominator has an x minus 2. So this right here can give us an extraneous fake solution. So let's just take a look at this guy right here for a moment. This is an extraneous solution. What we do is we take that expression, x minus 2, and we set it equal to 0. And then we solve, which I think is pretty straightforward. You just add 2 to both sides. X equals 2. That is a fake solution. So if you finish the problem and this is the answer you end up with, it's wrong. You actually have a no solution. So we need to keep an eye out for this guy right here. And I'm going to add a slash through that. That means x cannot equal 2. If you get x equals 2, it is wrong, no solution. That's the only added step. Everything from there, I'm going to do exactly what I showed you on the front. And make sure you make this obvious. I put a star next to it, I boxed it, so I will not forget it's there when I'm done with the problem. All right, let's go back to just finishing the problem. We want to get the same denominator first, so let's work on that goal. I'm going to bring these down to give myself a little more workspace. 5 over x minus 2 plus 2 over 1, leave space after that before you write the equal sign, equals 17 over 6. These are the current fractions. Let's write down the fractions that we want underneath. We want them to have the denominator 6 times x minus 2. And now let's go and fill in the extra symbols, the plus and the equals. Don't forget those. Now we look at each of these and decide what do I need to do to change the fractions so that they have the right denominator. First fraction, we have x minus 2. We need the 6 times 6, top and bottom. So on the top, we now have 6 times 5, which is 30. Next fraction, we have a denominator of 1, so it's missing all of it, the whole thing. So we'll multiply that by 6 times x minus 2, top and bottom. I have 2 times 6 here. I will change that to 12. 12, and then x minus 2 after it. Lastly, I have 17 over 6. It's missing the x minus 2, so I'll multiply top and bottom. And for the top, I'm just going to bring both of these down together. 17x minus 2. Okay. At this point, make sure all three denominators are the same. If any of them are different, you cannot drop. That would be breaking the algebra rule. They are the same, so we can drop. To save myself a little bit of work, I did these in the previous notes, I'm going to go ahead and do this distribution when I drop the denominators and rewrite the equation. So we now have 30 plus 12 times x, that's 12x. 12 times negative 2, that's negative 24, equals 17 times x, 17x. And then 17 times negative 2, that's negative 34. If you wanted to drop the equation first and then distribute after that, that's fine. I've got one more thing I should do here before I start moving things to the left or the right side. Does anyone see it? Chase?
Combine like terms.
Combine like terms. You should notice I have some more terms than usual on the left side. That means you usually have like terms to combine. 30 and negative 24. Now I always underline those to emphasize we're not changing anything. Because I'll have students who will go plus 24, plus 24. You're changing the sign. When you're on the same side, do not change the sign, just combine. So, bring down the 12x. 30 minus 24, that's 6. 12x plus 6 equals 17x minus 34. Now we have an x on each side and a constant on each side. Let's take care of the x's first. Since neither of them are alone, I'm going to move the one I want to move, which is the 12. I always move the smaller one if I can. So we're going to do minus 12x, minus 12x. These 12s cancel. Bring down the 6. Equals 17 minus 12, that's 5. 5x minus 34. We are almost done. As you can see, I'm out of space, so I'm just going to go up and over here to finish the problem. 6 equals 5x minus 34. Two steps from here. First, we move the constant. That's a negative 34. I will add 34 to both sides. 34s cancel. 6 plus 34 is 40, equals 5x, last step. We need to get the x by itself. We'll divide off the 5 on both sides. 5's cancel, and we have x equals 40 over 5 is 8. After all that work, it's going to be a little hard to remember, but do a quick check and make sure the number you get here is not the extraneous solution. It's not. This answer is right. X is 8. Questions on number 4? That's the process. That's everything I have to show you. So we're going to do a couple more problems that are a bit higher in difficulty level, and then you'll have time to do the homework. Since you've seen it all out twice now, I will go a little faster. Number 5, 4 over x plus 2, put those in parentheses, plus 3 over x plus 4 equals 12x minus 3 over x squared plus 6x plus 8. Let's pause. We need to factor that. It's a trinomial, no GCF. Here's kind of the nice thing about equations. In order to make them not too complicated, we have to set it up to where it's a bit of an easier type. So the factoring here is going to be easy. Without drawing the ACB chart, does anyone have a wild guess what these factors might be? The other two denominators. If we made it a lot more complicated than that, this equation would be a nightmare to solve. But for good measure, I always like to draw the ACB chart, but 9 times out of 10, it's going to be the two denominators they've already given you. Just thought I'd point that out, save you some time and energy. A times C. A is 1, so 1 times 8. B in the middle is 6. And if we use the 2 and the 4 that are already there, 2 times 4 is 8, and 2 plus 4 equals 6. So yeah, those are the factors. X plus 2, x plus 4. That doesn't work all of the time. Use that carefully, but the majority of the time, especially in this class, that's going to work. Hopefully looking at that now you know what the LCD is. This fraction has x plus 2 and x plus 4, so that has to be part of the denominator, of course. The order does not matter, but I am going to flip it around so that it's the same. X plus 2, x plus 4. And then the other two fractions each have one of those parts. So that is our LCD. We can turn all three denominators into that. Before we continue, we have two x's here. That means we have two extraneous solutions. So we need to set both of these equal to 0 and solve. X plus 2 equals 0. X plus 4 equals 0. So we'll quickly solve for those. Minus 2. X equals negative 2. And minus 4. X equals negative 4. So we have two extraneous solutions to keep our eye on for this problem. X cannot be negative 2 or negative 4. So look out for both of those. If we get either of those numbers at the end, it is no solution. All right, let's solve like normal. Again, just so I can write everything out, show all the work, I'm going to write this out again. 4 over x plus 2 plus 3 over x plus 4. Leave some space before you write the equal sign. Equals 12x minus 3 over, I'll write the new denominator now, x plus 2, x plus 4. Next, I'll create the goal fractions underneath. X plus 2, x plus 4 on all of them. And then the symbols, we have a plus and an equals. Now we just need to figure out what each fraction needs to make that happen. First fraction, we have x plus 2, we need x plus 4. Top and bottom. So we now have 4 times x plus 4 on the top. Second fraction, we have x plus 4 and we need x plus 2. So times x plus 2, top and bottom. We have 3 times x plus 2. Last fraction, we already have the correct denominator, so we will just bring it down. 12x minus 3. Same denominator means we can drop and just focus on the equation. As I drop, I will also distribute to save myself a step later. Dropping my equation, we have 4 times x, that's 4x. 4 times 4, that's 16, so plus 16. Plus 3 times x, that's 3x. 3 times 2, that's 6. Equals 12x minus 3. And we start solving. Hopefully on the left you notice a lot of terms there. That means we can more than likely combine something. We have 4x and 3x, both positive, just add. 4 plus 3 is 7, so we have 7x. 16 and 6, both positive. 16 plus 6, that's 22. Equals 12x minus 3. Now I have a variable and a constant on each side. This is when I'm going to start moving things. I'm going to move the smaller variable, so the 7 is going to get moved. It's positive. I will subtract 7 on both sides. 22 is equal to, cancel that out, 12 minus 7 is 5. 5x minus 3. Couple more steps. I'm going to go up and over to finish the problem. 22 equals 5x minus 3. Home stretch here. We need to first move the constant, minus 3. We're going to add 3 on both sides. 22 and 3 is 25. Equals, bring down the 5x. Last but not least, to get rid of the 5, we'll divide both sides by 5. X equals 5. Make sure you get a quick look at the wrong answers box above of -2 and -4. I do not have either of those, so 5 is the correct answer. Questions on number 5 before I do my final problem? All right, flip it on over. We got one more to do. Same idea, but with A's. A instead of X. 2 over A plus 1 minus, we need to fix that. Change that to a plus. Since the next thing is just a number, you can just put a negative on that. You don't have to put -1 and multiply. You could just put a negative there. It's more so when you have an expression on top that you have to worry about drawing the -1. Equals -2 over A squared minus 1. Put the parentheses here. A squared minus 1, we need to factor that. Again, you can kind of look at the other denominators to get an idea of what that's going to look like. This is a difference of squares. Square root, front and back. Remember, square root of 1 is 1. It is a perfect square. Square rooting A squared, I have A's in the front, 1's in the back for square root of 1. And then we have the plus and the minus. A plus 1, A minus 1, which will be the LCD. The other fractions have one of those two parts, so everything is included there. Next, we need to address extraneous solutions. We have letters here. That's a problem. So I'm going to solve both of those for A real quick. A plus 1 equals 0. A minus 1 equals 0. Solve both of those. Minus 1 on both sides. A equals negative 1. Other equation, we'll add 1 to both sides. A equals positive 1. So these are the fake answers. That is what A is not allowed to be at the end of the problem. So keep an eye out for both of those. If I get either of those answers, it is no solution. Now that we've looked at extraneous solutions, we can go back and solve the problem like usual. I will write the problem down again. 2 over A plus 1 plus negative 1 over A minus 1, leave a little space, equals negative 2 over A plus 1, A minus 1. I'll set up the goal fractions below. A plus 1, A minus 1 in all of the denominators. And then don't forget the plus and the equal sign. First fraction has A plus 1. It needs A minus 1. So multiply top and bottom by A minus 1. Putting that together on top, I'll have 2 times A minus 1. Second fraction has A minus 1. It needs A plus 1. So multiply top and bottom by A plus 1. That gives me negative 1 times A plus 1. The last fraction is already good. Don't need to change anything, so bring down the negative 2. This will only take a couple minutes to solve. This is a very quick equation. We have the same denominator on all three, so we are now safe to drop the denominators and solve the equation on top. When I drop, I will go ahead and distribute to save me a little bit of time. Distributing 2 times A, we have 2A. 2 times negative 1, that's negative 2. Plus negative 1 times A, that's negative 1A. Negative 1 times 1, it's negative 1. Equals negative 2. Couple more steps and I'm done. First off, notice that there's quite a few terms here. We can combine like terms. 2A minus 1A. Again, use the signs that are there. 2 minus 1 is 1. So this is 1A. Negative 2 minus 1. We can also combine those. Negative 2 minus 1 is negative 3. Equals, bring down the negative 2. I've got one step. I need to move the 3. It's negative, so I will add 3 to both sides. Now this 1A, I'll drop the 1 and just call it A for simplicity. Negative 2 plus 3 is positive 1. And up in the right-hand corner, you can clearly see that A is not allowed to be 1. This is extraneous. Therefore, my answer is no solution.